Hello students, welcome to this video. I will continue with the chapter 5, periodic classifications of elements. I will continue with the modern periodic table. So this modern periodic table is according to the increasing atomic number. Just before this, when Mendeleev tried to classify elements according to increasing atomic mass, there was a problem. There were few problems and limitations due to which his table was to be rejected. But Henry Moseley, the scientist who converted this Mendeleev's periodic table into the modern periodic table by taking the increasing atomic mass, all the limitation or problem faced by Mendeleev was solved. And so whatever the table that we are using now at present, this one we call it modern periodic table or long form of periodic table. Till now there is no limitation or any anomalies in this modern periodic table. So we are following this modern periodic table. Let's further discuss with this. So this is the modern periodic table. If you count the column, the vertical column, you'll find that there are 18 columns, and these 18 columns we call it the group, 18 groups. And if we see the horizontal row, you'll find that there are 7. So there are 7 horizontal rows, and these are called the period. So in modern periodic table there are 18 groups and 7 period. But in Mendeleev's periodic table, what you found was that there were 8 groups and 6 period, and moreover in each group it was subdivided into A and B. So these are some of the difference. Again, in modern periodic table there are 2 rows found below the main table, and these 2 rows we call it the lanthanides and actinides. Actually these lanthanides and actinides belong to the 6th and 7th group. If you see the atomic number, that in the 6th period from say 57, in the 3rd group and 6th period, if you see the atomic number 57 to 71. After that the 72 comes in the main table. So from 57 to 71 it is put separately below the main table, and this one we call it lanthanides. And in the same way, from 99 to 103, it is not 89 to 103, this is put just below the lanthanides or below the main periodic table, and this one we call it actinides. So always there are lanthanides and actinides are there below the main table. So this is about the modern periodic table. There are various names given to this period and group. The first period, which consists of only 2 elements, hydrogen and helium, this is called the shortest period. The second and the third period, which contains 8 elements each, these are called the short period. And then 4th and 5th are called the long period, and the 6th, which contains the actinides, this is called the longest period. And 7, which contains, in the 6th it is the lanthanides, and in the 7 it is the actinides, and this is called the incomplete period. So these are the different names given for different period. Now, writing of electronic configuration. Electronic configuration means the distribution of electrons in the orbit. So to find the maximum number of electrons in each orbit, we use this Bohr-Bari theory. That one we call it 2n squared. So 2n squared is the formula. If we want to find the maximum number of electrons in first orbit, that is n equal to 1, n will give you the number of orbit. So if n is 1, that means the first orbit, you will find that the maximum you are getting 2 electrons. That means the capacity of the first orbit will be 2 electrons. And if it is 2, if n equal to 2, then it is 8. And if n equal to 3, that is for the third orbit, we get 18. So if you write 18 or 8, both are correct. It is because we will be studying only the lighter elements, maybe up to 25 or 30 elements. But if we study up to heavy elements or heavy metals like atomic number 70, 80, then only we use this 18th in the third orbit. Otherwise, for us, we will be using 8. So when in exam, if it comes and if you write 18 or 8, both are correct. So what does this orbit indicates in the periodic table? The first orbit indicates the first period. The second orbit indicates the second period. And the third orbit indicates the third period. That means if we are having 7 period in the modern periodic table, then the orbit should be 7 maximum, not more than 7. I hope you have understood this one. This is very important. If an atom of an element has only one orbit, that means that element belongs to first period. Or if the atom has got 2 orbits, then that atom or element will belong to second period. Or if an atom of an element contains 3 orbits, then it belongs to the third period in the modern periodic table. So by writing electronic configuration, we can find the position of elements in the periodic table. So number of orbit, we get it by writing electronic configuration, and by getting that number of orbit, we can find the period number, because the number of orbit will determine the period. Again, the position of an element in the periodic table tells us about the chemical reactivity of an element. Chemical reactivity of the elements, because according to the positions of the elements, the valency will come, and according to that valency, the reactivity of the elements are different. Now, how electronic configurations are written? Like say this atom always try to become balanced. Try to become balanced means they always try to attain the electronic configurations of nearest noble gas. So electronic configurations of nearest noble gas means it may be of the helium, that is 2, it may be of the neon, that is 2.8, or it may be of the argon, that is 2.8.8. So this is the atomic number up to 20 and electronic configuration. If atomic number is 1, then it is seen that electronic configuration is 1. If atomic number is 2, then also electronic configuration is 2. Then if atomic number is 3, then electronic configuration becomes 2.1. So up to 2, it is 1 orbit, because the first orbit can hold maximum of 2 electrons, not more than 2. So if number of electrons becomes 3, then it will start filling the second orbit. That is why if atomic number is 3, electronic configuration is coming 2.1. So it will go on increasing in that way till up to atomic number 10. If atomic number is 10, then electronic configuration becomes 2.8. So the maximum capacity of the second orbit is 8. If atomic number increases or the number of electrons increases to 11, then what it happens? It becomes 2.8.1. So 2 plus 8 is 10. Another 1 is there. It will start filling the third orbit. Since the maximum capacity of the second orbit is 8, it cannot be 9. That is why for atomic number 11, electronic configuration is coming 2.8.1. In the same way, it will go up to atomic number 18. If atomic number is 18, then electronic configuration becomes 2.8.8. So 2.8, it is 10, 10 plus 8, it is 18. So the maximum capacity of the third orbit is also 8, not more than 8. If atomic number becomes 19, that means number of electrons become 19, then electronic configuration becomes 2.8.8.1. So this third orbit also cannot hold more than 8. It cannot be 9. That is why the 1 electrons in the last will start filling the fourth orbit. So it will go on like that, like the atomic number 20, that is for calcium. The electronic configuration will be 2.8.8.2. So by writing the electronic configuration, we can find the position of elements in the modern periodic table. So as I have said, the number of orbit will determine the period. Like say if atomic number is 11, there are 3 orbit, that is 2.8.1, 3 orbit. It belongs to third period. Or if atomic number is 19, if atomic number is 19, electronic configuration is 2.8.8.1. There are 4 orbit, so it belongs to fourth period. So in this way, by writing electronic configuration, we can find the period in the modern periodic table. Now about the group, there are 18 groups. So group is determined by the valence electron. Valence electron means the outermost one, the last one. This is called the valence electron. Let's see, like say atomic number 4. In atomic number 4, electronic configuration is 2.2. We find that valence electron is 2. That means it belongs to second group. So valence electron will determine the group. Let's talk about say atomic number 11. Atomic number 11. Electronic configuration is 2.8.1. Therefore, valence electron is 1. It belongs to first group. So in this way, valence electron will determine the group. But there is an exception for second period and third period. For second period and third period, if valence electron is more than 2, then we add 10 to the valence electron to find the group. Just for example, say atomic number 5. For atomic number 5, electronic configuration is coming 2.3. So if it is 2.3, it should have been in the third group, but there is no third group in the second period. 2.3 belongs to second period, and in the second period there is no third group. So what we have to do, we have to add 10 to this 3, so it becomes 13. 3 plus 10 is 13. So atomic number 5, this will belong to the 13th group. Another example, you take it, say atomic number 15. Atomic number 15, electronic configuration is coming 2.8.5. Valence electron is 5 and it belongs to third period. Since this 5 is more than 2, so we have to add 10 to this 5, so it becomes 15. So atomic number 15 will be in the 15th group. Take it another example, atomic number 17, which is chlorine. Atomic number 17, the electronic configuration is coming 2.8.7. It belongs in the third period, so exception is for second and third period only, not for the first, fourth, fifth, sixth or seventh, only for second and third. So atomic number 17, it belongs to third period. Valence electron is 7, which is more than 2, so we have to add 10 to this 7, it becomes 17, so it belongs to 17 group. So in this way we can find the position of an element by writing electronic configuration in the modern periodic table. So this is about the electronic configuration or the atomic structure of some elements given here. So in the next video I will explain you about the trends in the modern periodic table. Trends in the modern periodic table.